Hello everybody. In today's class, we'll be discussing some of the points from the third unit of Basic Electrical and Electronics Engineering EI 105C. So we'll try to discuss the points related to third unit, that is nothing but switches and relays. So coming to the switches, we see uh, any if we see any circuit, we generally see one kind of or more than one kind of switch in any electronic circuit. So switch is a main component, or it makes a circuit to come into action. So this is how important a switch is about. So in today's class, we'll discuss some of the basic concepts and as well as some types of switches that are used in electrical or any other appliances. Okay, so we'll discuss first what are the learning objectives of today's video. So the learning objectives for today's videos is, the first point is, we'll try to know what is all about a switch and what are the components that make a switch come into action. And next we'll discuss the different types of switches that are commonly used. For this particular video, I'll be talking about 4 different types of switches. There are n number of varieties available with regards to switches, but for today's session we'll discuss 4 different varieties of switches, and in the next classes we'll discuss some other kinds of switches. Okay, so the second learning objective will be how the 4 different types of switches look like and how it works. Those points will be discussed, and later on we'll be ending our session with the applications of the switches. And before that, I'll try to show you some kind of switches that we commonly see in any circuits or any appliances. Okay, so let's get started and let's learn what is all about switch. So switch is an electrical component which can make or break electrical circuit either automatically or manually. So here the switch can be a manual operated type. So the manually operated switch is generally called as mechanical type of switch, where we physically operate the lever so that the switch operation can be observed. Whereas some kind of switches are also available where the physical action of any human is not necessary, like all the action will be done automatically, like in case of electronic switches or in case of electromagnetic relays. These kind of switches, the switching action will be done automatically. So don't think that if a switch is operated or the component which is operated manually, this is called a switch. There is nothing like that. Switches can be operated either manually or it can be operated automatically. So switch mainly works with 2 positions or 2 mechanisms. The first one is on position, that we simply call it as on means closed position, and the second one is off position. Off position is nothing but open circuit position. Either switch will stay in either 2 conditions, like in boolean or digital electronics we say it as on and off, or 0 or 1, or low or high. We talk in these terms, we'll talk in digital electronics. Likewise in switches, switch either stay in on position, that is closed loop condition, or in off position, that is open circuit condition, it will stay. So numerous circuits hold switches that control how the circuit works or actuate different characteristics of the circuit. An electrical switch is a device which is used to interrupt the flow of electrons in a circuit. Okay, so this is another way how we define a switch. So a switch can be either called as it is a component which makes or breaks electrical circuit, or otherwise it can be called as a device which is used to interrupt or allow the flow of electrons in the circuit. In either ways we can define a switch, like flow of electrons in a circuit, or which is used to make or break an electrical circuit. So this is the most commonly used definition for switch, that is switch is a component which makes or break electrical circuit. So switch essentially are essentially binary devices. They are either completely on, that is in closed condition, or completely in off position, that is open condition. Okay, numerous circuits hold switches that control how the circuit works or actuate the different characteristics of the circuit. The classification of the switches depend upon the connection they make. So depending upon the various connections, the type of connection that we make, switches can be classified. So for this classification, two main components are there that confirm what sort of connection a switch makes, that is pole, and the second one is throw. So pole and throw will confirm what sort of connection a switch is making, or what kind of switch it is defined by two components, that is nothing but one is pole and the other one is throw. So number of poles is the number of separate circuits which are connected by a switch, and number of throws is the number of separate positions that a switch can adopt. So number of poles means the number of separate circuits, whereas number of throws means number of separate positions the switch can adopt. Okay, so poles means nothing but how many circuits it is controlling, it is defined by poles, whereas number of throws indicates the number of positions, in how many positions. For example, if we take a fan regulator, the fan regulator have 5 or 6 different speed control positions. So we can say that the number of throws for a fan regulator is 5 or 6. Okay, so the number of positions that is taking shows the number of throws that particular switch is having. Okay, for example, a single throw switch has one pair of contacts that can either be closed or open. That is, this example confines to a normal switch which we use for switch on and off or fans or lights. So that kind of switch is nothing but a single throw switch where we either on or off, that is only one connection or one circuit is connected, either one light or one fan or one load is connected to it. So we say it as a single pole, and the number of throws will be also one, as the number of positions, either it go into on condition, otherwise it get back to its off position. That's all. Other than that, it does not go into any other position. So we say that a normal switch which has a single throw has one pair of contacts that can either be closed or open. A double pole switch has a contact that can be connected to either of two other contacts. Okay, so double pole switch, like for example, if we again take an example of light dimmer circuit, or like volume controllers or fan regulators, if we take, it have more than one positions that it can take. So there we see more than one throws. So if we take two throws, then it is called as double throw switch. A triple throw has contact which can be connected to 1 to 3 other contacts. So depending on the number of throws, the positions or the number of separate positions that a switch can adopt will increase, and the number of and the different number of load variations can also be connected. And coming to the terms pole and throw, they are used to describe the switch contact variations. So this point we have already discussed, but we'll see it once again. Like, what is meant by pole? Actually, what defines a pole? The amount of circuits controlled by a switch is indicated by poles. Okay, single pole SP switch controls only one electric circuit. Double pole, that means DP switch controls two independent circuits. If it is a single pole, it controls only one circuit. Double pole, it controls two independent circuits. And coming to throw, the number of throws indicate how many different output connections every single pole can connect its input. A single throw switch is a simple on-off switch. When the switch is on, the two terminals of the switch are connected and the current flows between them. When the switch is in off, the terminals are not connected and so current does not flow. Okay, so this is all about switch and what are the components that make a switch. And next we'll discuss what are the different types of switches that are commonly available. So as I have already said that we'll discuss the basic 4 different types of switches for in this today's lesson video. That is, the 4 different types are shown on the screen. The first one is SPST, single pole single throw. So single pole single throw can be simply written as SPST. Second one is single pole double throw, so SPDT. So by the name itself we can analyze or understand what is the purpose or what this switch can do. Okay, double pole single throw, DPST. Next, DPDT, double pole double throw switch. So depending upon the number of poles and number of throws, we find 4 different types of switches, and there is another kind of switch which is based on number of poles and throw, that is multi-pole throw. So that point we are not discussing right now, as we'll confine our lesson only to these 4 points for today. Okay, so now we'll discuss all these in detail and we'll try to see how the symbols for these are given. Okay, now first we'll see single pole single throw switch working, SPST. So the working of SPST switch. So SPST means we have already discussed, that is single pole single throw, is a basic on-off switch that just connects or breaks the connection between two terminals. So this is a basic and the most common and the basic version of the switch is nothing but single pole single throw switch. Simply we can say that if we press the switch, the circuit will be on. If we again press the switch, the circuit will be off. That is, only one connection will be made and only one circuit will be in action. So that kind of switch is nothing but single pole single throw. So here this one is nothing but throw. The line which is raised above the circle is nothing but throw, and this dot is nothing but pole. Okay, when we push the switch onto this small circle, then the switch is said to be in closed position. When we push the wiper upwards, then we can say that the switch is now in open condition. For an open condition circuit, the resistance will be very high, so no current will be flowing in the circuit. Whereas when the switch is in closed position, that when the throw comes in contacts with the pole, that is this wiper comes and touches this small circle over here, then we say that the switch is in closed condition, and at this position the resistance will be very low and the current that is flowing in the circuit will be infinity or high. So this point is based on Ohm's law. So Ohm's law states that voltage is directly proportional to the resistance into current. More the resistance, lower the current, and lower the resistance, higher the current. So there is an inverse relationship between current and resistance. So based on that point, the amount of current that is flowing based on open and closed circuit conditions of the switch is defined. So these types of switches are also known as toggle switches. So SPST kind of switches are called as toggle switches. So I'll show you what this toggle switch is in the next slides. This switch has two contacts. One is input and the other is output. From the next diagram that shown in this slide, so here we'll see typical light switch diagram. It controls one wire, that is one pole, and it makes one connection, that is one throw. So here we see there is a circuit in which here we have a light over here. This light is getting controlled by this switch. So this switch is nothing but a single pole, single throw. So one wire and one connection is here. That is one wire means one pole and one connection is nothing but one throw. So here we have a power supply, and to that power supply we are connecting a switch, and to the other end of the switch there is a load. Here the load is nothing but a light. So what we are doing is that when we push the wiper of the switch downwards, or if the throw of the switch is thrown onto the pole of the switch, the light will be in on condition, or the light will be glowing as the current will be flowing in the circuit. As the circuit is made, if we break the circuit or if we move the wiper or the throw from the pole into upward condition, there will be a breakage in the circuit as it is shown in the diagram. Now the circuit is in, or the switch is in open condition. So as the switch is in open condition, there will be no current flowing in the circuit, and this also indicates that the resistance is high as it is open circuited, and the light here which is connected as the load will not glow. So we don't see any load at the output. Okay, so this is a basic on off switch. When the switch is in closed, or when the current flows through the terminals, and the bulb in the circuit will glow. Okay, when the switch is in open or in off, there is no current flowing in the circuit and the light will be in off condition and it will not glow. Okay, so this is a basic example for single pole, single throw. So there will be only one wire connection and one circuit will be connected at all the times. Okay, got the point? The symbol for this SPST is this one, and one of the applications that we can mention is this circuit. Right, next we'll move on with the single pole double throw switch, SPDT. Single pole double throw switch is a 3-terminal switch, one for input and the other 2 for the outputs. Here this is a symbol for single pole double throw. So whereas here you can see that A, B are two different positions. So this A and B are nothing but that are used to connect the outputs. So these are nothing but throws. Two different connecting circuits or two different connections can be made. So this diagram, or in this figure, we can see that there are two different throws and there is only one pole moving in between them. That is, only one input is connected to two different inputs. Okay. It connects a common terminal to one or other of two terminals. Okay. So for using the single pole double throw as single pole single throw switch, then we use COM terminal instead of other terminals. For instance, we can use COM. For instance, we use COM and A. Either we can use COM and A, then it makes a single pole single throw. Or otherwise, if we use COM and B, then it makes a single pole single throw. So single pole double throw switch is nothing but, it is an extended version of single pole single throw switch, where we see uh, instead of one throw we see two throws. So instead of one circuit we can connect additional another circuit can be connected. Okay, so if we connect COM and A, this is one single pole single throw. If we connect COM and B here as shown in the diagram, then it is nothing but single pole single throw. If we connect A, B and COM into a circuit or making it as a switch, then we can call this switch as single pole double throw switch. Okay. Now we'll see one diagram which is very much similar to the previous one, that is SPDT connection light switching circuit. So here I have used a single pole double throw switch. So the power supply used is same. The switch that we are using here is a single pole double throw. Double throw means here we can connect two different circuits. So that's why I have connected two different bulbs or lights here. So you can see a light here, light A on the upward side and light B below it. So the terminal A is connected to light A, then it is directly getting connected to the power source. Next, the terminal B is connected to light B and again it is getting connected to the power supply. Okay, so as we have two different throws, two different lights can be used in this circuit and two different lights can be operated alternately. If we want to turn on the light A, light B goes off, or if you want to turn on the light B, light A turns off. In that is, any one of the light will be in on condition at one time. But no two lights or both of the lights will not be in on condition at any point of time. That point is to be kept in mind regarding double pole double throw switch. So double pole double throw switch, though it has two different connections or two different circuits may be connected, but at any point of time only one switch will be or one circuit will be in working condition or it will be open circuited. The other one is closed circuited. Okay, so as shown in the on the screen, now the switch is connected to the throw is at terminal A. So we can simply say that light A will be glowing and light B will be ignored. So light B will not glow in this position. Whereas if this single pole double throw is connected to terminal B instead of terminal A, then the light B will be glowing and light A will be in off condition. Okay. So this circuit, it clearly demonstrates what happens when the single pole double throw switch is moved back and forth. These switches are used in a three-way circuit to turn on a light on and off from two locations, such as from the top and bottom of a stairway. When the switch A is closed, then the circuit flows through the current flows through the terminal and only light A will glow. That is, the light A will be on and light B will be off. When the switch B is closed, then current flows through the terminal and only light B will be on and light A will be off. Here we are controlling two circuits or paths via one way or source. So this kind of switches where we see near our staircase, like inside we'll have on the bottom of the staircase we might have one switch, and the top of the staircase we might have another switch, but both the switches will operate the same kind of loads. Okay, there we can use single pole double throw switches can be used. So this is nothing but we are controlling two different circuits with only one way or source. Okay, next we'll see what is all about double pole single throw switch. Double pole single throw is abbreviated for double pole single throw. This we know. Double pole means the unit contains two identical switches side by side and operated by a single toggle or lever. This means the two separate circuits are at a time controlled through one push. Okay, so in this diagram we can see the same thing what I have said right now. Okay, so double pole and single throw connection switch will look like this. Okay, a double pole single throw switch turns two circuits on and off. So as it has two poles in the previous example, using two lights, there is only one pole. Here we have two poles, so two different circuits on and off can be done. Double pole single throw switch has four terminals, two input terminals and two output terminals. Okay, so single pole double throw has three terminals and this one has four terminals, whereas the initial one, starting one, that is single pole single throw, has only two terminals. So single pole single throw has two terminals, single pole double throw has three terminals, and double pole single throw has four terminals. For of these four, two will be input and two will be output. Okay, the most common use for double pole single throw switch is to control a 240 volt appliance where both supply lines must be switched, while the neutral wire may be permanently connected. Here, when the switch is toggled, current starts flowing through two circuits and interrupted when it is turned off. Okay, so this is how a double pole single throw switch works. Okay, all the switches might look same or the functionality will remain the same, but depending upon the poles and throws number, the connectivity or the number of connections that are being connected and the number of circuits getting turned on and off will vary. Okay, next we'll see what is meant by double pole double throw switch. So DPDT is a double pole double throw switch which is equivalent to two single pole double throw switches. This we have already discussed, single pole double throw. For a single pole double throw switch, we'll have three terminals. Just now I have said we have terminal A, B and a COM. So when single pole double throw switches, when two are taken and connected together, then it forms a double pole double throw switch. So double pole double throw switch is nothing but two single pole double throw switches. Okay, so it routes two separate circuits connecting each of two inputs to one or two outputs. The position of the switch determines the number of ways in which each of the two contacts can be routed. Whether it is on or on on modes, their functions like two separate single pole double throw switches, that is SPDT switches, operated by the same actuator. Only two loads can be on at a time. As we have two poles here, that is, it is double pole, two poles will be in action at any time. That is, only two loads can be on at a time. Though we have four different connections here at the output side, but only two will be in action, or two will be in on at a time. A double pole double throw switch can be used on any application that requires an open and closed wiring system. For example, railroad modeling system, if we take, which makes use of the small scaled trains and the railways, bridges and cars. The closed circuit allows for the system to be on at all the times, while the open circuit allows for another piece to be turned on or actuating through the relay. Okay. So from this circuit, here the connections A, B, C from one pole of the switch, and the connections D, E, F from another. So the connections B and E here are common in each of the poles. If the positive power supply enters, that is positive power supply, here it is nothing but Vs. If the positive power supply Vs enters at connection B and the switch is set to the topmost position, and the connection A becomes positive, and the motor will rotate in one direction. Okay, so if the switch is set to the lowermost position, the power supply is reversed and the connection D becomes positive, then the motor will rotate in the opposite direction. In the center position, the power supply is not connected to the motor and it does not rotate. This type of switches are mainly used in various motor controllers where speed of the motors is to be reversed. Okay, so these kind of switches we commonly see in motor controllers, so where this speed control of the motor is to be reversed. Okay, so this is nothing but one of the example for double pole double throw switch. Okay, now we'll see one video which describes or shows the different types of switches that are commonly available in the market. Okay.
In other words, it can make or break an electrical circuit. Every electrical and electronics application uses at least one switch to perform on and off operation for the device. So, the switches are the part of a control system, and without it, control operation cannot be achieved. A switch can perform two functions, namely fully on by closing its contact or fully off by opening its contacts. When the contacts of a switch are closed, the switch creates the closed path for current flow and hence load consume the power from source. When the contacts of a switch are open, no power will be consumed by the load. There are mainly two types of switches: mechanical switch and electrical switch. Mechanical switches require physical or manual contact with switch for operation. Electrical switches not require physical or manual contact. It has ability to perform operation. Electrical switches operate under the action of semiconductors. Mechanical switches further classify into different types of switches based on number of poles and throws. There are 5 types. 1. Single pole single throw SPST. 2. Single pole double throw SPDT. 3. Double pole single throw DPST. 4. Double pole double throw DPDT. 5. Intermediate switch. Mechanical switches can also be categorized on the basis of holding the current state. There are 2 types: latch switch and momentary switch. The latch switch holds its state whether on or off until the new commands initiated this switch. And momentary switch holds the state only when the specific command is presented only. Latch switch and momentary switches are 8 types. 1. Push button switch. 2. Limit switch. 3. Pressure switch. 4. Float switch. 5. Temperature switch. 6. Toggle switch. 7. Rotary switch. 8. Joystick switch. SPST, single pole single throw. The SPST is a basic on or off switch that is used to connect or break the connection between two terminals. The power supply for the low circuit is given by this switch. The application of SPST switch is light switched and it is also called as a toggle switch. This type of switch has one input and one output. SPDT, single pole double throw. The SPDT switch is a 3-terminal switch. One terminal is used as input and remaining 2 terminals are used as outputs. It joins a mutual terminal to one or the other 2 terminals. The application of SPDT switch is mainly involved in a 3-way circuit to turn on or off a light from 2 locations like from the top and bottom for stairway. DPST, double pole single throw. The DPST switch consists of 2 poles, that means it includes 2 identical switches located on side by side. This switch is operated by one single toggle, which means that 2 discrete circuits are controlled at a time through one push. DPDT, double pole double throw. This switch is equal to 2 SPDT switches. It means 2 separate circuits. Connecting 2 inputs of each circuit to one of 2 outputs, the switch position controls the number of ways and from the 2 contacts, each contact can be routed. Intermediate switch. An intermediate switch is where 3 points control the same circuit. This is a very versatile switch and can be used for most lighting situations. But in reality it is more expensive, so you would normally only use it when needed.
So in this video we have seen how the different types of switches look like single pole, single throw, all the 4 different types what we have discussed right now are shown in that video. And we were discussing only one kind of or one sort of switches right now. In the later sessions we'll discuss the other kinds. So as of now we have discussed only the mechanical kind of switches where we manually operate. So that is nothing but 4 different types have been discussed, and the last one, that is nothing but rotary switch or intermediate switch, that we have not covered in this presentation. But this rotary kind of switch or intermediate switch is nothing but a multi-way multi-position switch. That is, it may be costly, but it have a different throws, different number of throws are available, where many circuits can be connected via a single pole. Okay, so these are the switches that I thought of discussing for today's class. And coming to the applications of switches, I mean not only SPST, SPDT, DPST, DPDT, in a generalized version or in general sense, the basic applications what we see for switches are these. So we'll see one by one what are these. So the applications of switches are nothing but either in access control, like entry or exit control, in aircrafts, in ammeters, in appliances. Like in any appliances, right from a single simple torchlight to appliances like microwave ovens, or in any other or in any electronic appliances or home appliances, we use switches compulsorily. It may be any kind of switch, not only the switches that we have discussed. Switches are of many types. Those any from those, any one kind of switch can be used. And in braking system, conveyor systems, in cranes, doors, and in electropneumatics, emergency stopping systems, escalators, HVAC, high voltage alternating current. That is, next is we'll be using in hydraulics, ignitions or starters, that is in automobile industry, like either in bikes or cars. Like we see a bike starting turning on by just by the movement of a key, or just by pressing the push button. So there also will be using switches. And in instruments, all electrical and electronic instruments will be using, or in our electronics or electrical laboratories also, we see switches for all the instruments that we handle. And in machine tools for every motor, and in pneumatics, and in pressure vessels, pressure controller, safety interlocks, scrubbers, separators, speed control, sumps, tanks, transformers, valves, and voltmeters. These are some of the applications where we find uh, switches. Okay, so not all the applications uses a single kind of switch. Each one uses uh, each one uses a different kind of switch based on its application. Some may be using push button switches, some may be using toggle switches, some may be using binary switches, some may be using temperature switches, some may be using slider switches, some rotary switches. So based on the application, for that particular application we will be selecting a different kind of switch. Okay, so for this class we'll stop the discussion for today, and in the next coming classes we'll discuss other different kinds of switches that are available, and their usage and as well as applications will be discussed in the next coming classes. Okay, thank you.